All right, folks. So we did 6-1 last time we had class. I'm on the very front page. We're going to start day 2 of that here in a second. So far, what we should have accomplished, if you look at this, is we should have a general understanding of learning target 4, which is I can use the quotient property to simplify expressions. Quotient property means what math operation is happening?
The divided one.
It's division. What do you do with the exponents when you divide?
You subtract.
Subtract them. Okay. We should also have a good understanding of the product property. Okay, product property means what math operation is happening? Multiplication. And what do you do with exponents when you're multiplying? Add them. Okay, and then last one, power exponent. So that's one exponent to a second exponent. What do you do with exponents when that is the case? All right, otherwise we're going to move on to 6-1 page 5, day 2. Using 0 exponents and negative exponents. All right. So this is actually of the chapter, the second learning target, the ability to use 0 exponents to simplify expressions. Okay, 0 exponents. For any non-zero number, a to the 0 power is 1. It's just 1. With the exception of trying to take 0 to the 0 power. That does not work. Okay, so you're always going to want to try to identify what the exponent is being applied to, and whatever it's being applied to, that will just be 1. All right. So algebraically speaking, if I have x to the 0 power, x to the 0 power is, let's go back, for any non-zero number, doesn't matter what it is, a to the 0 power is 1. So x to the 0 power is 1. So anything to the 0 power is 1. Okay, what about 4 to the 0 power? What's that? 1. Okay, fairly easy. Okay, now what I'm going to do is I'm going to attempt to explain why this works. Okay, and so what I am going to do is I am going to give you just like a mini proof like we're in a geometry class here. And try to explain it. Okay, so let's assume that I have like 4 to the 3rd power, and I'm dividing it by 4 to the 3rd power. Okay, 4 to the 3rd power divided by 4 to the 3rd power. Okay. I'm dividing. So what's my division rule of exponents? To subtract exponents, specifically top minus bottom. So I'm going to go 4 to the 3rd minus 3. And what is 3 minus 3? So this is 4 to the 0 power. Any questions about this? Okay, this is division. Division tells me to subtract my exponents. 3 minus 3 is 0. All right, now I'm going to do the same thing, but it's going to look different. 4 to the 3rd power divided by 4 to the 3rd power. Instead of doing the exact same thing I did over there, I want to represent it in a different looking way. So how can I expand 4 to the 3rd power out? What is that? How can I expand 4 to the 3rd power so I can figure out what number that is actually equal to? I don't want to know what number it is. I want to know how can I figure out what the number is. What do I have to do to determine that number? 4 to the 3rd power. 4 times 4 times 4. And then 4 to the 3rd power, it's going to be the same thing. 4 times 4 times 4. Okay, so what I'm going to do is I'm going to take my calculator. It is 64. 4 times 4 is 16. 16 times 4 is 64. What's 64 divided by 64? 1. So here I have 4 to the, these are obviously the same, right? 4 to the third power divided by 4 to the third power. Okay. But I know 4 to the third power is the same as 4 to the 0 power. And I know 4 to the third power is also the same as 1. So what do I know about 4 to the 0 power and 1? So these things are the same. And these are the same. And these are the same. So what do I know about these two things? They're also the same. So that means 4 to the 0 power is indeed 1. Now, if I wanted that to be like a formal proof, I would have to use variables, but you could do the exact same thing. All right. Let's do some examples. More or less like what your learning target stuff's going to be looking like. All right, ready? 4a, q to the 0 power. Okay, what about 3x to the 0 power? Now, my guess is based on everything that I've just explained to everybody here, is that you are going to want to say 1. And it's not. So this is where 0 exponents and negative exponents that we'll deal with in a little bit are going to differ from each other a little bit. Is what you want to keep track of is this. I think I spelled that right. The exponent's only being applied to the x because there's no parentheses. Since it's only being applied to the x, what I have is 3 times x to the 0 power. X to the 0 power is what? 1. So what I have here is actually 3 times 1. And 3 times 1 is 3. So you have to be careful. Yes, 0 exponents are extremely easy to deal with because it's 1. But there are some certain ones that you want to be careful about because they're just got to kind of pay attention to your order of operations. First thing in order of operations is exponent. Okay, same thing here. I would read this out loud visually or verbally as the opposite of x to the 0 power. There's no parentheses around the negative sign and the x. So that means this exponent's going to happen first. So yes, so it's 1. X to the 0 power is 1. The opposite of 1 is negative 1. Okay. Any questions about 4a, b, or c? Okay. Try monitoring progress 10, 11, and 12, and then we'll check it over together here in a quick moment. All right, 10. K to the 0 power. Opposite of y to the 0 power. Okay, 16 times y to the 0 power. It is going to be 16. It's 16 times y to the 0 power is 1. 16 times 1 is 16. Okay. Is there anything I need to clarify with negative or not with negative, with zero exponents. Zero exponents are just one. Yeah, that's right. Finding that right there. Yeah. Okay. We good with that? Okay. All right, negative exponents. Okay, so negative exponents are probably going to throw you off a little bit more than the typical one will. All right. Okay, for any integer n and any non-zero number a to the negative nth power is just the reciprocal of a to the n. Okay, so we probably will want to know what the word reciprocal means. Does anybody recall what the word reciprocal means? We have most definitely done things with exactly the word reciprocal in this class. It's not quite opposite, but I understand why you would say opposite. It's not quite opposite though. Yeah, it's like flipped is a pretty good word for it, right? So if I want the reciprocal of 2/3, it would be 3/2. If I want the reciprocal of 1/4, it would be 4/1. What if I wanted the reciprocal of just 7? It'd be 1/7, because 7 is the same as 7/1. Okay, so algebraically speaking, if I have a to the negative nth power, that is just going to be 1 over a to the n power. Essentially, your rule is if the exponent is negative, not the base, if only the exponent is negative, you are going to put it under 1 and make the exponent positive. Okay, so 4 to the negative second power, it is going to be under 1 and make its exponent positive. And that's how you're going to do negative exponents. Okay. Here's why. Let's say I have 4 to the third power divided by 4 to the fifth power. What math operation am I doing here? Division. What's my division rule tell me to do? Subtract my exponents. And you're going to subtract top minus bottom. So I got to go 3 minus 5. Three minus 5 is -2. Okay, so I know 4 to the third is the same as 4 to the fifth, or over 4 to the fifth is the same as 4 to the negative second. Okay, and now I can do the same kind of concept as we did on the other page. How do I find what 4 to the third is? Like, what do I have to do to determine that number? Okay, 4 times itself 3 times on the top and 4 times itself 5 times on the bottom. Okay, we talked about this last time we had class. If I take 10 and I multiply it by 2 and then divide it by 2, what am I left with? 4 or 10 times 2 divided by 2. What am I back at? 10. So if I multiply and then divide by the same number, it accomplishes nothing. Nothing happens. Okay? Because it cancels out to 1. So I can do that same thing here. I'm multiplying by 4 on the top and dividing by 4 on the bottom. Boom. They do nothing. So I can cancel them out. Okay? Same here. They cancel out. And same here. So when they all cancel out on the top, what's left over is 1. It's 1 times 1 times 1. Then here, 4 times 4, it is 16, but it's also what? It's 4 to the second power. So what do I have? I know that these are the same. 4 to the third divided by 4 to the fifth. 4 to the third divided by 4 to the fifth is 4 to the negative second. I know that 4 to the third divided by 4 to the fifth is the same as 1 over 4 to the positive second. So what do I know about these two things? They are also the same. When you get to geometry and use that a lot, it will be called the transitive property. Okay. Let's do a couple examples. 5A. Okay, 5A, what I am going to do is, it is a rule. There's only a couple exceptions. I couldn't honestly tell you why. There's only a couple exceptions. You never write your answer with a negative exponent. So your answer always has to be resulted with a positive exponent. So let's go ahead and do W to the negative fourth power. What do I have to do to make that happen? It's going to be 1 over W to the fourth. Or I put the W under a 1 and make its exponent positive. If you're looking for just the kind of cheap trick to get you to the correct answer. Okay, 5B. One over 4 to the third. Okay. Now on this one, I can simplify 4 to the third because I can determine what 4 to the third is. Okay. So 4 to the third, how do I determine that? How do I find what number 4 to the third is? Times it by itself 3 times. 1, 2, 3. 64. My expectation is I would see both of these from you. Not just one, not just the other, but both of these. So does everybody know how to get to this, the positive exponent? Okay, and then we all know how I got to 64. Okay, let's do 5C. How do I determine 5C? All right, 1 over 2 to the fifth. Then I should probably figure out what 2 to the fifth is. 1, 2, 3, 4, 5. Wait, no, that's 5 to the fifth. I want 2 to the fifth. 1, 2, 3, 4, 5. 32. Thought that looked correct. Okay. Is there anything I can clarify on those three? Okay, 13, 14, 15, try those, and then we're actually almost done with the lesson for today. So everybody should get their learning targets done again. Hey, maybe somebody I haven't heard from. 13. Somebody I haven't heard from yet today. Yeah. 1 over y to the third. Okay. Looks good to me. Do I have to simplify this? Because, yeah, we don't know the value of y. And until I do, I'm not going to be able to figure out exactly what that's equal to. Okay, somebody different from 14? Go ahead. Okay. And this one has the same issue as the previous one. I'm not going to know what x to the 15th is, or x to the 5th is, unless I knew the value of x. Okay, and then a third different person would be great. 415. Yeah.
1/16.
Okay. 1 over 16 to the power of 1. And do we know what 16 to the power of 1 is? Just 1 over 16. This one happened to be a little extra easy. Okay, good. Good. Hey, are we good with that? Okay. One last little section. This next section, what we're going to do is we're going to take the rules from day 1, and then we're going to mix them with the rules from today. Okay, so if you were gone, or you maybe forgot the rules over the weekend, you were about to be retaught all of them. Okay, using quotient, product, and power rules, but the only difference is we're going to get to negative and zero exponents. Okay, so first off, quotient means what math operation? What does it mean when I'm asking for a number's quotient? What are you doing? Quotient. So the quotient of 3 and 6. What is it asking you to do? What math operation? No, product would be multiply. So if you're multiplying, that means product. What?
Division.
It's division. Okay, quotient means division. What's your division rule? What do you do with exponents? You subtract exponents. Product means multiplication. What do you do with your multiplication rule? Add. And then power rule is exponent to a second exponent, double exponent, maybe triple exponent. You multiply the exponents. Okay, so let's look at 6a. What math operations happening with 10 to the 4th and 10 to the negative 6th? Multiplication. So I'm going to use my product rule, my multiplication rule. What is my multiplication rule? What do I do when I multiply? What do I do with the exponents? I add them. Multiplication says I add the exponents. So 4 plus negative 6. Base stays the same. Notice I'm not going 10 times 10 to get 100. I'm keeping the base the same, and then I'm adding the exponents. 4 plus negative 6 is negative 2. So I get 10 to the negative 2nd power. Can't leave my answer with the negative exponent, so what do? 1 over 10 to the 2nd power. And what is 10 to the 2nd power? 1 over 100. And I would expect to see both of these. Okay, how did I know to add the exponents? Because I was multiplying. What about B? What's happening on B? I'm division, dividing. What do I do with my exponents when I divide? I subtract top minus bottom. So I'm going to have negative 4 to the 2 minus 7 power. 2 minus 7 is, so negative 4 to the negative 5th power. Negative, or 2 minus 7 is negative 5. How do I make its exponent positive? Okay, this is the first question I got. Was, do I change the base? No, base stays the same. My base is negative. My answer there will be negative also. Okay, and then I have to figure out what 4 to the 5th, negative 4 to the 5th power is. How do I do that? What do I do? Okay, I'm going to take -4 times itself 5 times. 3, 4, 5. She's calculator for that. -1024. Okay, z to the 4th power to the -3rd power. Multiply. I have a power to another power, and I multiply my exponents. So I'm going to take z to the 4 times -3 power. So then I get z to the -12th power. And then to simplify it to get an exponent that's positive, I'm going to put it under 1 and make its exponent positive. Okay, 6D. What math operation's happening? Division. When there is dividing, I do what with the exponents? Okay, so I get y to the 11 minus 11 power. 11 minus 11 is? Y to the 0 power is? So in black, that's what quotient, product, and power means. Quotient means division, product means multiplication, power means exponent to second exponent. In red is what you do with the exponents. Okay, so quotient does not mean subtract. Quotient rule means I subtract my exponents if I want to do the shortcut. Okay, anything needed clarification there? Okay, go ahead. 16, 17, and 18. So 16, I'm dividing. Since I'm dividing, I subtract my exponent. 6 minus 6 is 0. Anything to the 0 power is 1. 17, power to power, I multiply my exponents. -2 times -1 is +2, so 6 to the positive second power. 6 to the positive second power, 6 times 6 is 36. Okay, x to the third times x to the negative third would be x to the 3 plus -3, which is x to the 0. Anything to the 0 power is 1. Q to the third divided by q to the fifth is q to the 3 minus 5. 3 minus 5 is -2. Q to the negative second power is the same as 1 over q squared. Okay, that is it from this day's worth of work. Okay, so 5 through 10, number 29 and 30. Okay, I'm going to ask that you do all of these problems to get the learning target. And then with the exception of you can skip 9 and 10. You should be able to do 9 and 10, but 9 and 10 are more have more layers to them than the other ones. So if you're asking what's the bare minimum you have to do to get the learning target, it's all of these except for 9 and 10. Okay. Yeah. Everybody, I think, should be done with the practice problems before lunch. And then you can learning target after lunch if you want to. So everybody should get done today. Otherwise, that's it for the day.